Hi, I'm Paul. We are doing Leetcode Maximal interview questions, also known as the top interview 150. This is actually number 150 out of 150. So I'm going to have to find something else to do with myself going forward. Anyway, today's challenge is maximal square. Medium rating given an M by N binary matrix filled with zeros and ones. Find the largest square containing only ones. Containing only ones and return its area. All right. This example 2 is not very interesting. Example 1, well, there's two squares here, each of which is 2 by 2. Consisting of only ones, and what did it say? Return the area. So it's 2 times 2, and then we would want to return 4. All right. Well, it's a dynamic programming problem, as you can see here. So let's sketch out how this works. It's actually not super complicated. You know what? It would be better if we could see the matrix and write things at the same time. What if I move it here? Yeah, that should be enough room. All right, I'm going to draw some stuff. I'll be right back. All right, so this is our dynamic programming table. It's the same size as the original table. Well, I shouldn't say that. It's one. The dimensions are the size of the original table plus 1 in both directions. We just need that for padding. We pad it with zeros to make the algorithm work. We're going to go through the. We're going to iterate through the table that we're given, the input matrix, and we're going to consider each square with a 1 in it as the possible lower right hand square of a larger square. And we can compute that, how large a square we can make with that, by taking the minimum of the adjacent squares. And by adjacent squares, what I mean is the square above it, the square to the left of it, and the square to the top left of it. So, let's go through this and see what I'm talking about. So, we are in the first row of the input matrix. There is a 1, but none of the surrounding cells are 1s, so we have to go with a 1 here. It's 0 plus 1. The next is a 0. Then we have another 1, but again, it's surrounded by 1, so 0 plus 1, it's still 1. And then the next 2 are zeros. Okay, second row. This square here is a 1. We take the minimum of the surrounding squares, which is 0, add 1 to it, and we get 1. Next square over is a 0. Next square over is a 1. The minimum surrounding square is a 0, so add 1. We get 1. This square is a 1. So we add 1 to the minimum surrounding square, which is 0, and get 1. And over here, add 1 to the minimum surrounding square, which is 1, and we get 1. All right. We're in the third row. Oh, these are all 1s. All right, so this is a 1, but it has zeros as 2 of the surrounding cells. So we add 1 to 0, we get 0. This is a 1, but it also has a 0 as a surrounding cell. So we add 1 and we get 1. This is a 1, but it has a 0 as a surrounding cell. So we get 1. This is a 1, and the minimum surrounding cell is actually a 1. So that goes to 2. All right, now this square over here, the last square in the row is also a 1, and the minimum surrounding square is a 1, so that goes in as a 2, meaning that these squares with the 2, if we consider those as the lower right-hand square of a bigger square, then we can make a 2 by 2 square out of them. And finally, the last row, this is a 1. It has 0 surrounding it. It's still a 1. This is a 0. This is a 0. This is a 1 with a surrounding 0, and this is a 0. So keeping track of the maximum in the DP table is 2, but that's the length of a side of the square, and it says to return the area, so we square it to 2 squared and return 4. All right, so let's take a look at an implementation. All right, so here's what the implementation looks like. We get M and N as the dimensions of the input matrix, and then we define a dynamic programming array. M plus 1, N plus 1, dimensions of the matrix plus 1 in both directions. Max, this is where we keep track of the maximum side of a square that we can make. All right, so we have a nested for loop. It iterates through every cell of the array. It looks for a 1 in the matrix. And if it finds a 1, then it's going to, well, Java will only take 2 values at a time in the math min function. So we got 2 math mins here, but it's going to look at the 3 surrounding cells. So I plus 1, j plus 1. This is looking at the cell above it. This is looking at the cell to the left of it. This is looking at top, left, and whatever is the minimum, we add 1, and we put that in the dynamic programming matrix. We look and see if what we just put in there, which is this, is it greater than the previous max that we've seen? And if it is, we store it in max. All right, once we get through iterating through every cell in the array, we've got the max value, but it doesn't say to return it says to return the area of the square. So it's max times max. And let's try it. All right, accepted. Submit. Oh, check out the badge on the profile. Oh, I got a badge. Okay. Whoa, what just happened? Wait a second. Come on. Just give me the regular solution here, will you? All right. 7 milliseconds. Okay, that's good. That's what most people got. Okay, so that's maximal square. And I hope you enjoyed it. Please feel free to like, subscribe, comment, and see you next time with something new.